What's up, everybody? Got another video here for you. This one's a calculus video, and we are going to use double integrals in polar coordinates. So it says a cylindrical drill with radius 5 is to be used to bore a hole through the center of a sphere of radius 6. Find the volume of the ring-shaped solid that remains. All right, so let's draw a picture of this. Now, I'll warn you right now, my picture's probably not going to be that good, but we will do the best we can. All right, so we have a sphere here. I can draw it better than that. So we got something like this. So we got a sphere here. Well, that's fine. All right, and then we have a cylinder that's going through the sphere. Okay. And it's making a hole in the sphere. All right, so let's draw it looking in the XY plane. So if we do that, so that's kind of like if we're up here at the top looking down, this right here in the XY plane. Well, for the sphere, you're going to see a circle. All right, and then you'll see another circle where the cylinder is. And this circle here, the cylinder has a radius of 5, so that's 5. And the sphere has a radius of 6, so that's going to be 6. Let's see if I can make that 5 look a little better. All right. And this is what we're looking at, this part right here. Okay. All right. So if we look at the sphere, we know the sphere has an equation of x squared plus y squared plus z squared equals 36. We got the sphere, we centered it at the origin. So it's x squared plus y squared plus z squared equals r squared, and r is 6. The radius of the sphere is 6. All right, so what we're going to do here is we're going to set this thing up into a double integral using polar coordinates. All right, so if we look at this right here, this equation here, we can see that x squared plus y squared plus z squared equals 36. Just write it down again. So we get z squared is equal to 36 minus x squared minus y squared. And so z is equal to the square root of 36 minus x squared plus y squared. So what I did is I factored a negative out. I took the square root. Now, keep in mind, it is plus or minus the square root of this, okay? But I'm just going to look at the plus. I'm just going to look at the top half of it, okay? The top half of the sphere is z equals the square root of 36 minus x squared plus y squared, and the bottom half would be z equals negative square root of 36 minus x squared plus y squared. All right, so we're going to deal with the top half. So what we're going to do is we're going to find the volume of the top half and then double it. Okay. All right, so let's look at this. So we are going to set up our integral, and we're going to set it up with polar coordinates. Now, if we rewrite this in polar coordinates, that's going to give us the square root of 36 minus, and we know x squared plus y squared is r squared, and then that's times r dr d theta. And our bounds on the integral for r is going to be from 5 to 6. So that's 5 to 6. And then our bounds for theta, that's going to be from 0 to 2 pi. We're going all the way around. So that's 0 to 2 pi. All right, so now what we can do to solve this is we can set this up 0 to 2 pi d theta 5 to 6 square root 36 minus r squared times r dr. Okay, so I split the integral, I separated the two, and I'm going to multiply the results. All right, so this first one right here, that's just 2 pi. Oh, I'm sorry. And so the volume equals, and we're going to have to double it. Okay, so we'll double this. I forgot to put the 2. All right. So let's integrate this thing. So I'm going to let u equal 36 minus r squared. So du is negative 2r dr. We're using new substitution. So I've got to multiply by negative 2. So I've got to come out here and multiply by negative 1/2. And so this is going to be 2 theta from 0 to 2 pi. I'm integrating that. And that's going to be times negative 1/2. All right, so now what can we do? We can plug the u in for 36 minus r squared, so that's u to the 1/2, right? Change the square root to a 1/2, and then you can see that the negative 2r dr, that's going to be replaced with du, and so that's du. And so this is going to give, one more thing. Now, since we're in terms of u, we're going to change the bounds on our integral. We're going to put them in terms of u. See, these values here, the 5 and the 6, that's r values. Well, we got to put them in terms of u. So I get u is equal to 36 minus 5 squared. So that's 36 minus 25, which is 11. And u equals 36 minus 6 squared, which is 0. So that's 11 to 0. Now, what I like to do is I like to have the lower bound on bottom and the smaller number on bottom and the larger number on top. So I'm going to swap those. But let's go ahead and evaluate this. So that's 2 times 2 pi minus 0. Just plugged in the 2 pi and the 0. Times, and that's going to be 1/2 times the integral 0 to 11 u to the 1/2 du. So remember, when you swap the bounds, that changes the sign in front of the integral. And so this is going to be 4 pi times 1/2, and that's going to be u to the 3/2, right? Add 1, and then multiply by the reciprocal of your new exponent, so that's times 2/3. And that's going to be from 0 to 11. And so this is going to be 4 pi times 1/3 times, well, let's see, we don't need to put let's just put a multiplication. All right, and that's going to be times 11 to the 3/2 minus 0 to the 3/2. And this, when you punch all that into your calculator, you get 76.40954989. And that would be the volume of that ring that it leaves. Okay, and like this part right here. All right, so I hope that video was helpful. It's a pretty good problem. It's not very difficult. It really helps to change to polar coordinates, makes our integration easier. All right, so check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.